Reservoir, the beginning of the city's drinking water system. It is located on 6 Mile Creek, approximately 1.8 miles upstream from the treatment plant. The 60-foot dam was built in 1912 in response to population increases that created a need for a more stable drinking water supply. There is a siltation pond above Burns Road that captures large material and prevents it from silting in the reservoir. The reservoir and siltation pond need to be regularly dredged to maintain capacity. The water in this creek is relatively clean, based on sampling conducted by local watershed groups and volunteers. This is mostly because there is no history of industry, intense development, or commercial farming in the watershed. However, 6 Mile Creek was the outlet for the last glacier, which means the stream banks are loaded with glacial silts and clays. The water carries a large amount of sediment during rain events. Sediment removal is the biggest challenge of the treatment process. An oxidizing chemical is added to the raw water from the reservoir immediately. This reduces organic matter, which helps eliminate disinfection byproducts in the treated tap water. 6 Mile Creek also has natural manganese that must be monitored and removed. The oxidant makes manganese easier to remove in the treatment process. Manganese is not a major health concern, but it discolors water and stains fixtures and laundry. The water and oxidant travel through a 24-inch line to the water plant. The plant is rated for 4 million gallons a day, with room to upgrade to 5 million gallons a day if needed. Average production is between 2.5 and 3 million gallons. Current water treatment plant was completed in 2017 on the same location as the original treatment plant, which was built in 1912. The raw water from the reservoir enters the plant here. Chlorine dioxide is immediately added to remove any remaining organic matter and manganese. Chlorine dioxide is fast-acting and does not require the same contact time as the first oxidant. Chlorine dioxide is made on site. Rotometers control dosing of the 3 chemicals that generate the chlorine dioxide. The final product will be a yellow-green color. A long-chain sticky polymer called coagulant is added to bind small particles like silt, clay, and bacteria. It facilitates removal of that matter through settling. The coagulant, chlorine dioxide, and raw water are rapidly mixed, forced up vertical pipes called static mixers. The water is now considered coagulated and heads to slow mixers and the settling basins. Slow mix basins allow the coagulated water to bind particulate matter together and grow larger until they begin to settle out by gravity. This is called flocculation. The water leaves the slow mix basin and proceeds up through structures called inclined plate settlers. These structures replaced passive settling basins and are much better at removing fine particles. As the water travels up, the solids are settled out by gravity. The settled solids are collected at the bottom of the basin and are moved to an off-site facility for dewatering. The clarified or settled water is then collected at the top of settlers and heads to filtration. A major upgrade to the facility was the switch to membrane filtration units that replace sand and coal beds. Membrane filtration provides a more constant finished product and allows for future process upgrades. There are 4 filtration units. Each unit has 62 modules containing 6,350 membrane fibers and can produce up to 1 million gallons daily. Each module is monitored for turbidity, operating pressures, and flows. The modules use these readings to perform self-cleaning. Operators perform a more intensive cleaning on units as needed. Water enters the base of each module as shown here. The fibers are like straws with porous walls. Under pressure, the water is forced from the outside of the fiber to the inside through a 0.1 micron pore. The filtered water is collected from the inside of the fibers at the top of the module via the blue tube visible at the top of each module. Bacteria and particulate matter are left behind on the outside of the fibers and rinsed away during cleanings. Corrosion inhibitor is added right before the water enters the clear wells. The The purpose of this chemical is to coat the pipes in the distribution system, which prevents copper and lead from dissolving into the water. The filtered water heads into storage basins called clear wells. There are 2 located underground outside of the water plant. Chlorine is injected just prior to the clear wells. The clear wells are baffled to create a maze-like path that slows the water movement through the basins and provides adequate contact time with the chlorine. Water quality is tested throughout the process at the water treatment panels. The panels capture data such as temperature, flow, turbidity, chlorine residual, coagulate dosing, pH, and others. The operators view these values at a glance in the control room. Sample taps provide easy access to water from different treatment stages for lab tests. Here, a lab technician is running a chlorine test on finished water. After all the treatment processes and testing, finished water enters the distribution system and heads up to your tap. Approximately 70% travels by gravity to the downtown area. The remaining 30% is pumped to either East Hill or South Hill areas. Do you want me to say the hook?